Hello, everyone. Once again, it's Ray Aslin, Fortinet trainer. I teach the public cloud security course, and I have a video for you today. We're going to go over AWS lab number 5. In other videos, we've done labs number 1 and 2 in a single video, deployed a FortiGate into simple topography with a public subnet and a private subnet. I won't go through the details of that video. If you haven't gone through the videos for labs 1, 2, 3, and 4, I would definitely visit those videos before you visit this one. We will build on skills that you used in those videos. We'll also build on specific topology resources that we built in earlier videos. In fact, we will take the cluster that we created in Lab 4 in the very last video, and we will use that as part of our topology that we're deploying in Lab 5. Let's take a look at what we're going to go deploy in lab number 5. Well, first of all, let's just remember what we deployed in lab 4. So on the left side of this diagram, let's give myself a drawing pen for just a second. Choose pen color, and let's go with red. Very good. In lab number 4, we built this cluster. This cluster is a FortiGate clustering protocol, FGCP cluster. It's doing high availability, and it's doing it in an active-passive fashion. The weakness of that FortiGate clustering protocol is the fact that it is active-passive, and in order for a failover event to occur, there's an HA sync subnet right between these two guys where a heartbeat occurs, and let's just say for the sake of argument that this is the current master or active cluster node, primary cluster node at that moment. If it fails, this one has to go tell the cloud to fail over resources towards it. And if you recall, one of the things that could fail over was an elastic IP address. So an elastic IP address on the public side, EIP. Once again, you're dealing with my very wonderful screenwriting, handwriting there, which is only marginally better when I use a paper and pen, by the way. Just to be completely honest, I have bad handwriting on the best of days. Not only do we have that, but we also have a private routing table that moves the route from that elastic network interface to that elastic network interface. And that all occurs because the new master, or the new primary node of the FortiGate cluster, tells the AWS cloud that those resources need to be moved over to it. And if you didn't notice a little bit earlier, when that occurs, it takes time. It takes, well, how long it takes can be a little bit unpredictable. It takes as long as it takes AWS to process those API commands. The actual detection of the failure took very little time. As I recall, we did a little debug there, and we debugged the AWS daemon. And when I turned off, when I shut down this FortiGate, almost immediately there was debug output, basically telling the cloud to move those resources over. So that was pretty fast, the actual telling it. The actual response to it is unpredictable. We don't really have control over how fast the AWS API is going to respond to that. But I would say on a good day, it's going to take you many seconds, probably less than a minute, but certainly many seconds, many tens of seconds. So 20 seconds, 30 seconds, 40 seconds, probably less than a minute. And that's how long failover takes to occur in that active-passive method. So the active-passive method is useful, but it has some weaknesses. It has some limitations. Another method that we can use to do high availability is to do active high availability with a load balancer. Let's erase the ink that I have here. So when you do active high availability, you put a load balancer in front of your FortiGates. This is a public load balancer in this case. So the elastic public IP address is a listener on the load balancer. That's supposed to be EIP. Elastic IP address is a listener. When folks hit that elastic IP address, the load balancer can distribute those connections to a group of FortiGates. Now, ordinarily, I think I would expect to see this use a group of standalone FortiGates. So if you can imagine, we could add more FortiGates. Let's imagine we had a third FortiGate and a fourth FortiGate over here, and it could load balance to this one, this one, this one. As it's load balancing to these FortiGates, it's doing health checks. It's making sure that the connection to that FortiGate is still available. So once a health check fails, and we can tune how often the health check occurs, how many health check failures are missed, or how many health checks are missed before we mark that as failed. We can also tune how many health checks pass or are responded to before we consider it a good resource again. But within that tuning of how often we send the health checks and how many are missed, as soon as we determine that it's failed, we no longer load balance to it, and we can continue to load balance to the other FortiGates. So we have an active system where all the FortiGates that are being load balanced to are being assigned sessions by the load balancer, are being distributed sessions by the load balancer. Now, what's going to look a little bit strange is the fact that we're going to take one of those FortiGates is actually going to be a FortiGate cluster. So that will be the target of the load balancer. And I'll be honest, that's probably a little bit unusual. The reason that we're doing this is so that we can recycle resources that we created in Lab5. As you can imagine, when a courseware developer is developing a course, they don't want you to have to redo the same lab steps over and over again. So rather than have you create multiple new FortiGates, we're going to reuse that cluster as the target for the load balancer. And we will, let's go ahead and erase all of my drawing there. We will have you deploy just one new FortiGate right here, one new FortiGate. That's what we'll have you deploy in terms of new FortiGates. Otherwise, if we deleted this, we could deploy another standalone FortiGate here. And by the way, if you ever take the full course and you're going through the lab guide, that will be a note in the lab guide. It'll say you may use the previously created FortiGate or FortiGate cluster for this lab and create an additional one for the secondary availability zone. We'll get to the secondary AZ part here in a second. We're just recycling existing configuration. So if you're looking through this and thinking, so I'm always going to use the load balancer in front of FortiGate clusters. No, that's not true. In fact, although you certainly can, I suspect you'll use the load balancer in front of multiple standalone FortiGates. And we'll look more closely at that as we continue through the lab. So let's go ahead and erase those. Now, obviously our goal here is high availability. That's the goal. And if our goal is high availability, it makes sense to spread our resources within a region into multiple availability zones. If you don't remember what availability zones are, go revisit the AWS self-paced videos that discuss the AWS module. They'll discuss regions and availability zones. Basically, every region is subdivided into a number of availability zones, and those availability zones don't share power, they don't share networking, they don't share environmental controls, so that failures, like a power failure, shouldn't knock out multiple availability zones in the same region at the same time, since they're using different sources of power, different sources of networking. I like to picture them as individual data centers in a region. So if I'm using US East 2 in Ohio, I have each availability zone I sort of picture as an individual data center in Ohio with separate power, separate networking, separate environmental controls. So we want high availability. We're going to want to spread our resources between multiple availability zones. Yesterday, when we deployed this cluster, it was in US East 2, Ohio, availability zone number 1, which is sometimes listed as US East 2A. So availability zone 1 or availability zone A. Well, we're going to want to put the other resources in availability zone B or availability zone C, but we don't want to put them in availability zone A. We don't want to put them in the same AZ. We would like for this topology to be able to survive a complete availability zone failure, so that if AZ1 fails, the load balancer, which is a region level resource, can load balance to FortiGates that live in other availability zones. If we were going to deploy this topology in production, we might include some other configurations, some other resources that we're not going to include for keeping our example simple. Obviously, if we're talking about inbound traffic, folks hit the elastic IP address. The elastic IP address load balances to a FortiGate somewhere, and that FortiGate has a VIP. And that VIP will forward traffic to whatever the resource is that we are trying to send traffic to, a web server. In this case, we'll use RDP just for simplicity and familiarity. Everybody's probably seen an RDP connection before, but it could be a web server, a database server, whatever type of resource it is that we are trying to allow access to. And since those resources themselves could be spread in multiple availability zones, we could even have that VIP point to an internal load balancer. So we'd have another elastic load balancer that the VIP's pointed at, and then that load balancer could distribute traffic to internal web servers or whatever the application was that we were distributing access to. For the simplicity of our example, we won't go that far. We will configure the second availability zone, and we'll configure two subnets for that second availability zone, a public subnet and a private subnet in that second availability zone. We will configure a FortiGate that connects into both of them. We'll put a Windows server in this second private subnet. So this will be private subnet number 2. We'll put a Windows server in the first private subnet. We'll call that private subnet number 1. And we will simply load balance this way. We'll hit this elastic IP address, and if everything is working the way it should, sometimes we should load balance to this group of FortiGates, sometimes we should load balance to that FortiGate, and we should be able to bring up RDP. While hitting a single target, we should be able to, the target being the elastic load balancer, we should be able to distribute our traffic to both Windows servers at different times. That's what we're going to deploy. Let's erase all of this, go back to a regular mouse pointer. Go. Let's, erase and normal mouse, there we go, minimize that down. Just a little bit of review. We have FGT1 and FGT2, which are the high availability cluster that we deployed into availability zone 1. Now, for those of you that are very eagle-eyed, you might notice that this cluster has slightly different instance IDs from what you saw me create in the Lab4 video, slightly different elastic IPs from what we did in the earlier video, and that's because I did the earlier video 24 hours ago, and through the magic of the internet, we have skipped that 24 hours. Yesterday, I ran out of time to get to this lab video, so I went ahead and deleted that cluster, and I redeployed it this morning so I could use it in Lab5. So it's the same configuration that we saw before, but if you're looking really closely, you might say to yourself, boy, I thought the public IP address was slightly different when I saw Lab4's video. It was, but by the power of pre-recorded videos, I have masked you from the process of watching me redeploy it a second time a little bit earlier today. So there's nothing to see here. Don't mind the sleight of hand. I'll just use the magic of video to skip that part. You can just go right to the end where we have this cluster available. Let's really quickly just look. There we go. Availability zone 2A. 2A, yes, those are both in availability zone number 1. Okay, there's our PDF diagram. Let's put this off to the side. And let's go ahead and start our deployment. The best place to start is to create those new subnets in our VPC. So we'll go over to Services, VPC. We'll go to the subnets option. Let's just very quickly review the existing subnets that we have. We've got the public subnet 10.0.0.0/24. We've got the private subnet right here 10.0.1.0/24, And then we have two subnets that exist really for the management and functionality of the HA cluster. We've got the HA management subnet and the HA sync subnet. Since in our new availability zone, we're not setting up an HA cluster, we're just going to set up a standalone FortiGate, we won't need an HA management and an HA sync. Now, all of these are in US East 2A, or availability zone number 1. So our second public and our second private subnet will need to be in a different availability zone. Let's go ahead and create them now. Let's call this public 2. We'll use the VPC that we created earlier. Now here for it says availability zone, no preference. I do have a preference. And we'll put it in US East 2B, or availability zone number 2. I will pick another subnet in the 10.0/16 range. There we go, 10.0.10/24. So 10.0.10/24 is public subnet number 2. And we'll create another subnet. We'll call this private 2. There we are. Use the same VPC. Availability zone B. Remember that this is going to have a FortiGate that connects into public 2 and private 2. So while public 2 and private 2 should not be the same availability zone as the earlier created resources, they should be in the same availability zone as each other. Let's go back to this diagram very quickly so I can show you what I mean by that, because I think this could get confusing. And let's just add a drawing tool. Drawing tools, pen. So I've got this FortiGate. It's going to have an ENI that plugs into public subnet 2. It's going to have an ENI that plugs into private subnet 2. And both of those subnets should be in a different availability zone than the earlier created resources. But they do need to be in the same availability zone as each other. An EC2 instance can only exist in a single AZ. So if you could imagine that I created public in AZ2, but then I made private 2 in AZ3. Right? I put it in some other AZ. This FortiGate would only be able to plug into a subnet in this with the same availability zone as itself. Let's go ahead and erase that. And normal drawing mode, minimize this down. Okay. And we'll make this 10.0.11.0/24. And we'll hit create. By the way, you might notice that my browser is prompting me with certain IP subnets. That's because I run these labs quite often. And as I run them quite often, I have typed this in before, and my browser is trying to prompt me with input that I've given it in the past. So certainly, if you're doing this on your own, it's not going to prompt you with those existing subnets. Well, let's get this out of the way. I didn't mean to select it. So if we're following the lab guide precisely as it's written in the normal class, they're going to have us do something which I don't commonly do outside of a lab. They are going to, rather than use an elastic IP address on this new standalone FortiGate, it's going to have us use a public IP on it. And I know that sounds a little confusing because you're thinking, well, Ray, an elastic IP address is a public IP address. And you are correct, an elastic IP is a public IP address. But an elastic IP is actually a static public IP address. First, you have to allocate one, then you get the static address, and then you have to associate it with a resource, either an ENI or an instance. We tend to do them with ENIs. As we covered earlier, you can't associate it to an instance if that instance has more than one elastic network interface, more than one ENI. Well, I suppose for simplicity, they decided rather than having to allocate another elastic IP address and give it to the public interface of the second FortiGate, we would simply give it something that's called a public IP. These public IPs are IP addresses that are assigned to resources that are public, and they're treated a lot like elastic IPs, but they're dynamic in nature. If you turn a VM off and you turn a VM back on, then that will have quite likely have a new public IP address, unlike an elastic IP, which is static. Once you allocate it to yourself, it does not change. So if I was doing this and I wanted to be able to have a management IP address to be able to reach that FortiGate, this new FortiGate that I was deploying, I would almost certainly use an elastic IP, which is a step that you learned earlier. But since my role here is to facilitate showing you what's in the full-blown course lab, we're going to do it the way the course lab has it written, which will be a little bit more simple, I suppose. We're going to use one of these dynamic public IPs. So what I'm going to do is I'm going to take public subnet number 2, where that new FortiGate is eventually going to connect or attach, if you will. And I'm going to right click on public subnet 2. I'm going to choose modify auto assign IP settings. And you see this option right here, enable auto assign public IPv4 address. I'm going to go ahead and enable this. So when a VM is created and it's connected into that public subnet or public to that public subnet, as you go through the instance launch wizard, as you create that virtual machine, by default, it will get one of these dynamic public IPs. Now, it is still possible in that instance launch wizard to tell it not to give you a public IP. If you want a dynamic public IP, the EC2 launch wizard is the only time when you can make that decision to deploy it with that public IP or not. So when I enable this, I'm basically enabling a setting that says in the EC2 launch wizard, automatically turn on this public IP setting. And if I put my mouse over the little infographic there, it says automatically request a public IPv4 address for instances launched into this subnet. If enabled, you can only assign a public IP address to an instance that has a single new network interface with a device index of ETH0. This is simply another way of giving a resource a public IP. And outside of the fact that it is dynamic and not static, it works just fine. But I generally like the idea of it being static. That's why I like elastic IPs. Let's go ahead and save this. By the way, just so that you can contrast the difference in those settings, I'm going to show you the same setting on public just to confirm that we don't have it turned on there. Modify auto IP settings. See there it is. It's not enabled there. So every time I plug something into public, it doesn't automatically try to assign it this public IP. Very good. Next, we need to deploy some Windows instances. We're going to deploy a Windows instance into the private subnet, and we're going to deploy a Windows instance into the private 2 subnet. Let's go do that now. I'm going to go back to the VPC dashboard so that I can click on Launch EC2 Instances. I also could have gone to the EC2 console and clicked Launch EC2 Instances there. I'm just really demonstrating that either one of those methods would have gotten me to this screen. So Windows Server 2016, we'll search for that. Oops, enter, search for that, there we are. Windows Server 2016, and we'll choose base right here. We'll use a T2 micro when this comes up because that is the least expensive instance I can create. And the first one I'm going to plug into the private subnet. So there'll be one instance. Ideally, I would go, oh, well, let me launch 2 at one time. And that would be okay, except I need these to plug into different subnets. And each time you run the instance launch wizard, it only lets you pick a single subnet at that time. So I'm going to say one instance. I am going to change the subnet to the private subnet, which is in US East 2A. And you'll notice this is the public IP address assignment I was referring to earlier. You'll notice that it defaults to use subnet setting, which is disabled. If I were, in fact, plugging this into public 2, let's see what it would have said. Public 2, use subnet setting enable. This is the setting that I controlled when I turned that auto public IP address setting on. That's what I was controlling. Now, I actually don't want to put this in public 2. I do want to put it in private 2, and I do not want it to have its own public IP address. So I'm just going to leave that exactly like that. Now there are some other steps here. I can go look at storage, I can add tags, and if I go through the next button, that's what it'll ask me for next. I don't need to change either one of those things. So rather than clicking next at the bottom, I'm gonna go right to step number 6, configure security group. First of all, I want you guys to take a note of something. If I say select an existing security group, I do have some existing security groups here. Let me just go back and check my configure instance screen. Previous, I'm gonna have to choose something before I go forward. So I'm just gonna choose the Windows security group. I'll go to previous and previous and previous. I just wanna double check, yep, I am in private 2. I'll tell you why I double checked that I was in private 2. And I may have misstated this in an earlier video, which is why I'm going to bring it up now. In my mind, I really remembered security groups being a availability zone level resource. So if you create a security group in one availability zone, it's not available in another availability zone. It looks like I was wrong because I'm deploying something in a new AZ and I see earlier created security groups. I see the one that I created all the way back in lab number 1, where I allowed RDP and HTTP traffic in labs 1, 2, and 3. So perhaps I was remembering something about Microsoft Azure, or perhaps I was just wrong. It does happen from time to time. I will misspeak or misremember something. But I do have an existing Windows security group. If I didn't want to use this existing Windows security group, I could create a new one. And I suppose since I only need RDP for this and I don't want to open any extra ports, I will go ahead and create a new security group with just RDP. I'm not going to call it Launch Wizard 1 because I won't remember what that is. Windows Lab 5 RDP only. That's what I'll call that. Since I don't really like the description, I'll just use the same thing for the description. Very good. And I'll go ahead and review and launch that. By the way, if you're paying attention to this warning down here, all the warning is telling me is saying, you know, you're going to be allowing access to any source from the internet to be able to access this. And I am aware of that, but that's okay. I'm going to put this behind a FortiGate, and the FortiGate can further control access. So let's just say review and launch. And it'll ask me to confirm what I have. I'll go ahead and tell it to launch. I'll use the key pair that I created yesterday. Acknowledge it. Yes, I do have this file. Launch it. Let's go take a look at the instance and give it a name. I'm going to call this Windows Private Subnet because it's on the first. In fact, I'll call it Windows Private 1 Subnet, just so I don't get it confused with the Private 2 subnet. There we go. Actually, as I think that through, this is on the Private 2 subnet. Let me go ahead and change that name. Private 2 subnet. Here we go. And if I wasn't certain that it was on the Private 2 subnet, I could scroll down here and look at its private IP, 10.0.11. Yep, that's on Private 2. And if I still wasn't certain, because I couldn't remember the subnets, I could look down on subnet ID and oh, yep, it's definitely plugged into Private 2. So very good. I called it Windows Private 2 subnet. While that's finishing launching and initializing, let's go ahead and launch another instance because I need a Windows in each private subnet for this experiment. So I'll go ahead and launch an instance again. By the way, there's some neat tricks that you can do. I can come in here and I could say launch more like this. And all that really did was try to launch an instance with the exact same settings. So it's already picked the Windows Server 2016 base for me. It's already picked T2 micro for me, and those are appropriate. It also plugged it in the same subnet, and that's not appropriate. I don't want it with the same subnet. So what I'm going to do is I'm going to go backwards in the steps. I'm on step 7, review at the very top up here. There's step 6, security group, 5, add tags, 4, add storage, 3, configure instance. Let's go back to step 3 and make some slight changes. So now I can go back to step 3, and instead of saying private 2, I can simply say private. There we go. And I can say, now I don't need to do anything in storage, but I'm going to click next on this because I do want to show you something as we go through this. Storage, how big is its virtual disk going to be? That is plenty large enough. Now, tags. I skipped this a little bit earlier. I want to go ahead and add a tag. I'm gonna put in a tag called name, and I'm gonna set the tag name to Windows Private 1 Subnet. And what this is going to do is in the instance list, that column, that field that says name will already be filled out. I won't have to go in and name my instance after the fact. So if you are creating instances and you're using the launch instance wizard, when you get to the tags field, add a tag called name, N-A-M-E, capital N, just like that, and put whatever name you want. And then when you launch the instance, it will already have the name. I'll go over to security group now, and I'm going to go ahead and use the same Windows Lab 5 RDP only security group. No need to create that one twice. Both of these Windows systems should have the exact same ports open, so no need to create 2 security groups for it. Let's say review and launch. This should be better now, and click launch. Tell it I have that key pair, launch instance. Then we'll go to our list of instances. There we have it, Windows Private 1 Subnet. The name is already there, I don't have to fill it out. If we click on it, we can see it's in the 10.0.10 subnet. It's got 10.01.146. And if we still doubted it, we could look at the name of the subnet. The name of the subnet is private. Very good. So now we have, let's just remember what we've done here. We've created subnets in the second availability zone. We've created Windows instances in the first AZ and in the second AZ. Now I want to deploy a standalone FortiGate. Let's go back to our lab diagram for just a moment. And then this is something I will tend to do on the more complex labs. The more complex the lab is, the more I will refer back and forth to the diagram. Let me just go to the table of contents and choose lab number 5 and bring that over to the screen with us. Drawing tools, pen. So we deployed this, we deployed this, we deployed that private subnet, that public subnet. Now we need to deploy this FortiGate, and it's going to plug into this public subnet. Let's go do that next. Erase all the drawings and go back to a normal mouse button. In fact, move this over here so it's not in our way. All right, very good. Let's launch a new instance. This is going to be a FortiGate. I need to go down to Marketplace. This will be a pay-as-you-go instance. It's right here, Next-Gen Firewall, that's pay-as-you-go, as opposed to this one down here, which is bring your own license. Oops, a little trouble with my mouse. Let's try that again. There we go. Select. I don't want to deploy 642, so I'm going to say view additional details and deploy 625. Here we go. Continue to subscribe. These are steps that we did earlier, so I'm not going to speak through these steps as closely because they're the same steps that you did in lab number 1. I will choose 625. I will tell it that I want to deploy this to Ohio, and then I will say continue to launch. I am not going to make this is only going to need 2 instances, or rather 2 ENIs here. So I think I should be able to do this as a T2 small. Just to remind ourselves, when we did high availability, we chose a much larger instance type because we needed to have multiple ENIs. Generally speaking, if you're going to have more than 2 ENIs, you have to have more than 2 CPUs in your instance type. The only instance type that has less CPUs than ENIs are the single CPU instance types. The single CPU instance types will let you have 2 network interfaces. But for instance, if I needed 4 network interfaces, if I recall earlier, I think I did a C5 large with 8 EC2 compute units, 2 virtual cores. This let me create a total of 4 NICs. Maybe it was a C5 extra large. No, I think it was a C5 large. Generally speaking, you have to have at least as many CPUs as you want network interfaces, generally speaking. Actually, it may have been a C4 large. That looks a little bit more familiar. 8 compute units, 3.75 gigs of RAM. But at any rate, I was not able to do a T2 small earlier. Now with this one, I only need 2 network interfaces. One interface is going to go into public 2, a second interface is going to go into private 2. So T2 small should get the job done, and it will keep this lab as inexpensive as possible. I only have one VPC, so that's pretty easy to choose. And then I'm going to choose the new public subnet, public 2. It should have, now keeping in mind I can't see the subnet names, I should be able to decide which one it is a couple of different ways. First of all, it'll be in a new availability zone. As you recall earlier, my public subnet was in availability zone A, or US East 2A. So this should be something in US East 2B. I have 2 of them in 2B. One of them is public 2, one of them is private 2. The other way that I can look at this is pick one and look at the CIDR. Public was 10.0, 10.0. Private was 10.0, 11.0. So that one's private 2 to be specific. That one's public 2. And if I still couldn't remember, if I couldn't remember which one was public 2, was it 10.0, 10 or 10.0, 11, I could always go to another tab, go back to my list of subnets, and look at the subnet identifier. Fortunately, this is a really small environment, and I can keep track of all the subnets that we're using. Let's go ahead and for a security group, let's go ahead and use the same security group that HA is using, the FortiGate HA pair is using. That way I can basically edit a single security group and control what goes into all of my sets of FortiGates at one time. There we go. And then we'll choose the lab key pair that I created yesterday. All right, that should do it. We'll launch. Congratulations. Thank you. EC2 console. Should be able to go back and look at the list. When we get here, you'll notice there wasn't an option to edit the tags. So I will have to go in and say FortiGate Zone 2. There we are, T2 small, availability zone 2B. So I have a Windows system in availability zone 2B, and I have a FortiGate in availability zone 2B. There we go. Or really availability zone B. 2 is actually part of the region name. If I click on FortiGate zone 2, I can see that it's currently plugged into the public subnet. It says private IP address, but we know private IP doesn't mean it's the private subnet. It just means the IP address within the VPC. And I can see it's plugged into public 2. I need it to be plugged into private 2 as well. So I'm going to give you a few seconds to think about this. I have an existing instance. Where can I go on the screen? I'm just going to scroll here a little bit up and down. Where can I go on the screen to create that second elastic network interface? Where can I go to do that? I'll even look. I'll scroll down a little more. In fact, I'll scroll all the way down, let you look again. Right, network interfaces. If I go to network interfaces, I should have several network interfaces already created Yeah, several of them are for my FortiGate HA pair. Remember that those guys have 4 NICs apiece. The others that I see here are undoubtedly for my Windows systems. So I can see just based on the names of the security groups, right? The name of the security group attached to this one, Windows Lab 5 RDP only. This one, Windows Lab 5 RDP only. I like my network interfaces to have names because it makes it a little bit easier for me to sort through them later. So I'm going to go ahead and name these based on which Windows system they plug into. This is, as I look over here, it's in the second availability zone B. So I'm going to call this Windows Zone 2 ENI. And this one up here, I'm going to call Windows Zone 1 ENI. There we go, which means this one, which has the FortiGate security group on it that's also in Zone B, that must be FortiGate in Zone 2. So we'll call this FortiGate Zone 2, and it plugs into the public network, public to ENI. There we are. Now let's create a new network interface that'll be the same FortiGate. So this will be FortiGate Zone 2 private to ENI. And I'll just put that in my clipboard for a second. Which subnet do you want to plug it into? Well, the private to. Do you want it to auto-assign a private IP address or a IP address within that subnet? Yep, that's fine. I'll let that. I believe I've demonstrated to you a little bit earlier that we could do that differently. I could go in and put an IP. Let's go ahead and tell it to use the same FortiGate security group, just again for simplicity. And I'm going to go ahead and add a name tag to it. Name. I changed the description a moment ago, but I didn't change the name tag. And create. And that name tag is this name column right here. So that's why I added it. FortiGate Zone 2, Private 2, ENI. Basically the same name as what I did to the other one, but in the other one I put hyphens in here. So let's go ahead and put some hyphens in just so that it looks kind of consistent. Put a hyphen in there. Very good. So if I sorted by name, we'll see them there. FortiGate Zone 2, Private 2, FortiGate Zone 2, Public 2. Stretch that out. You can see it all. All right, so I've created the ENI, but that doesn't mean that, I named it FortiGate Zone 2. That doesn't mean that it's attached to FortiGate Zone 2. So let's go ahead and we could either go to Actions or we can right-click it. Let's right-click it and choose Attach. And we're going to go ahead and say FortiGate Zone 2 and click Attach. Now, if you recall all the way back from Lab 1, the private interfaces on our FortiGates, they need to have source and destination check turned off so that they can route traffic, so that we can have routes that point to them. So I'm also going to, while we're in the same screen, I'm going to go ahead and say change source and destination check and set it to disabled. Save. While we're here, let's just have another look around. 0, 1. I have my HA set, my HA pair of FortiGates, and they have their ENIs. And ENI number 1 on each one of them connects to the private network. So let's go ahead and check the source and destination check setting on those as well. Change source and destination check. Disabled. Well, that's not the default setting. I had to disable it on the other one. If you guys go back and watch the Lab 4 video, I never set this. Never set that. It was, so why is it set this way? That is not the default. You guys have seen me do these a couple times. Here, let's go take a look at Windows. We'll go look at, which by the way, we're not going to change Windows. I just want to confirm, yeah, the default is to have it enabled. How come ENI 1 on FortiGate 1 in the HA set automatically set it to disabled? Or if we go look at FortiGate 2 ENI 1, change source and destination check, also set to disabled. How come that is? How did we deploy those FortiGates? We didn't do an instance launch wizard, right? We did a CloudFormation template, and that's the trick. The CloudFormation template took care of that for us. So it's easy to forget about this step sometimes, especially if you've been deploying things using CloudFormation templates that you've gotten on GitHub, because CloudFormation templates do steps for you. That's the entire purpose. But remember, if you're doing things manually, that you have to go and double check settings like that. So that's where that came from. It came from the CloudFormation template. And if we dug through the CloudFormation template, we probably could even determine what line within the CloudFormation template in the JSON file actually did that for us. So routing table entries. We have these new public and private routing tables in the second availability zone, public 2 and private 2. We need to go manage our routing tables because in private 2, we need to be able to route out to the internet through the FortiGate. And then on public 2, we might need to add in a route that points to the internet gateway. So let's go to VPC. Let's go look at route tables. Public routing table. There are two subnets associated with the public route table. If we go look at subnet associations, let's scroll this up so we can see a little bit more. Here we go. The public subnet 10.0.0.0/24, the HA management subnet 10.0.4.0/24. Those are the only ones that are associated with that routing table. We also have the private route table, and currently the private route table is where everything else is associated. So let's just have a quick look here. Let's go take a look at routes. And this is something that I forgot to redo after I redeployed my FortiGate HA cluster. So I'm going to go ahead and fix this now. You see this black hold route right here, the 0.0.0/0 black hold route. This is black hold because this ENI doesn't actually exist anymore. ABA4. When I redeployed my HA set this morning, because I deleted it yesterday so I wouldn't be charged for it overnight, when I redeployed it, it got a new ENI. So this ENI, this old one, ABA4, doesn't exist. If I go and click on it, it comes up and tries to list it for me. It brings up the list of network interfaces filtered for that ENI, and it's not there. There is no ENI for that. So that's not going to work. So first, let's go ahead and fix that route on the private routing table. We'll go back to VPC, then we'll go to route tables, then we'll go to our private route table. Route tables. I'm going to call the private route table the private 1 route table so that it doesn't get confusing later because I'm going to have a second one. And I'm going to go look at those routes. I'm going to choose edit routes. And I've got this black hold route that says, hey, well, there's no ENI with that name. I'm going to change that to a different network interface. I might have to just delete it. I can't seem to get it to display the list. So let's go ahead and just delete the black hold route and we'll create another entry. 0.0.0/0, and we'll point it to an ENI, network interface. Well, maybe that's a function of the web page not working quite right. I'm going to save it without the routes, and then I'll go back and edit it and see if I can add it back. Edit, add 0.0.0/0, network interface. There we go. That's what we're looking for. So right now, the FGT1 is the active cluster node, the primary HA cluster node. So I'm going to set this to FGT1 ENI1. FGT1 ENI1. FGT1 ENI1 is the private NIC in that availability zone. And so hit save. There we go. And I need a second routing table that's going to apply to the private 2 subnet. Let's go back to our topology diagram for just a second, and I'll explain why I need that. There's our topology diagram. Bring this over here. So I have this subnet, drawing tools, pen, there we go. I have this subnet right here. And I'm creating a routing table for this subnet that directs this to route here. Now, HA will take care of moving that route over to the other network interface if this fails. That's not a concern that I have. HA will do that for me. But I have to set up my first initial route. So I've got that routing table that says you route for here if you want to get out to the internet. So it's a route to 0/0. That routing table would not work for this other subnet because this other subnet is in a second availability zone. It cannot have a route that says go to there in a different AZ. It needs a route that says go to here. And that's exactly what I'm going to give it. I'm going to give it a route that says if you're in the private 2 subnet, go to this to be able to get to 0/0/0. So let's go set that up for private 2. All the drawings, go back to a normal mouse. Let's create a new routing table. Let's call it private 2 route table. It's going to be for the VPC that we have been using. Click create. There's our routing table. Let's go up to private 2 route table. Let's edit its routes. Network interface. Which network interface? Zone 2, private 2, ENI, right? FortiGate, zone 2, that's the second FortiGate. The private 2 subnet created, subnet attached ENI right there. Save, very good. Now I need this to be associated with the private 2 subnet. So I'll go to edit subnet associations and I'll grab the private 2 subnet. All of these subnets that we see here in the middle are currently associated with the main routing table. Remember, the main routing table was the one that was associated with all the subnets in the VPC by default. So I'll click save. Yes, very good. I will also go in, just to be very explicit, and create a second public routing table. So we'll call this one public 1 route table, and we'll create another one called public 2 route table. Same VPC, create, close that, edit the routes. Oops, I've got the wrong one highlighted there. Public 2 route table that I just created, there we go, edit the routes, add a route that says /0, and tell it to use the internet gateway to be able to get out. Save that, close. Now let's go to subnet associations and get the public 2 subnet right there. Save. Very good. So I see one subnet association there. Once again, returning to our lab diagram. So we now have this subnet and this routing table that says to get to anything that's not in the VPC, go to that FortiGate CNI. We also have a public subnet routing table that says to get to, once it goes through the FortiGate and gets put out on that interface, to get to anything, go through the internet gateway. The internet gateway is a single configurational object for the complete VPC. So I didn't have to create a second IGW Authenticate Internet Gateway. I just reused the existing one. In fact, we probably could make an argument that I didn't even need to create a second routing table called public route table 2 or public 2 route table. I could have just used the existing one. However, for the ease of understanding and the ease of learning, I think it makes sense to have two public routing tables and two private routing tables so that you can logically separate those in your mind. Let's go ahead and erase all of that. Go back to a regular mouse pointer. Very good. Well, this is, we've been going for a little while here. I'm going to pause the video for a few seconds, go take a drink of water and give myself a little break. And when I unpause, we will continue. Be right back, everybody. Well, I hope you had a good little break. I hope you paused the video, walked away for a few minutes. I am ready to continue with you now. So I haven't changed the screen, at least I don't recall changing the screen. I think we're looking at the same screen that we were just looking at. So coming back to the lab diagrams, as I like to return to it. Find this PDF, here it is. Next thing that we're going to move on to is creating our firewall policies. So we're going to need an inbound policy with a VIP here that points to this IP address in the 10.0.11 network. And we need an inbound firewall policy here. And of course, this is HA, so we really just have to log into the active node, and the active node will sync it to the secondary node. And that will push an inbound policy there. So that's what we're going to do next. Let's go ahead and get rid of the ink there, erase all the drawings, regular mouse pointer, very good. So let's start off with that brand new FortiGate that we just created, the standalone. We'll go to instances. FortiGate Zone 2. That's the new one that we created. It's got two interfaces on it, one in the 10.0.10 network, one in the 10.0.11 network. Yep. And it has a public IP. There it is right there, public IP address. Now, just to follow up on our earlier conversation, up until now, when we deployed a public IP, it was an elastic IP. So you would say, well, for instance, FortiGate number 2 has a public IP, and it is the elastic IP, yes. Or so we look at this, and there's a public IP, but it is not an elastic IP address. So indeed, we do have a way to reach it. Let's copy to the clipboard here and open up a fresh browser tab in the background. There we go, advanced, proceed, normal certificate errors, accept. Admin, this is a freshly deployed FortiGate from the AWS Marketplace. So I'm going to need the instance ID. Move this little thing out of the way here. There it is, instance ID. It'll prompt me to change the password to something else, which I will do very gladly so that I don't have to type in that instance ID ever again. Very nice. And host name, we'll fix that later. First, let's go work on our port number 2 network interfaces. Port number 1 was a network interface that was attached to the instance when it was launched from the marketplace. So if you take a look at its settings, it's set to DHCP and it's already learned the appropriate IP address. Port number 2 we attached after the fact. So we will have to do a little bit of editing here. I'm going to give it an alias of internal. Yep, internal. For the sake of it, I'll say it's LAN. I'll set it to DHCP. It should learn a DHCP address. I don't want it to retrieve a default gateway from the server. The only gateway that I want it to use is on the public side. So that should be fine. We'll go ahead and turn on ping and HTTPS in case I need to reach it from the inside for some reason. Let's go ahead and click OK. And port number 1, I'm just going to give it an alias of public. Just so that when I'm creating things in firewall policy, the aliases make sense to me. And as you can see, the internal interface already received its IP address, 10.0.11.91, which should indeed match, 10.0.11.91 matches what the ENI is set to as well, which is, I would always expect that to be true. I think I would be shocked if I set this to DHCP and it got any other IP address, but it's nice to look. It's nice not to make assumptions. So let's go ahead and configure our VIP. So we'll go to policy and objects, virtual IPs. We'll create a new one once we get here. Yes, there it is, create a VIP. We'll call this Windows Server Lab RDP. We'll tie it to the public side interface, which has an IP address of, well, I hope that dog barking did not make its way through the video recording. I suspect it did. Welcome to the COVID world, ladies and gentlemen, where everybody tries to make business-like recordings and somebody's dog or baby cries in the background. So we're just going to ignore that and keep going. Here we go, port number 1. And we did say it was 10.0.10.110. Oh, 10.0.10.110. That's not confusing. External, 10.0.10.110. Mapped IP address. This is the Windows server in the private to subnet. So let's just go look at our list of instances. Windows private to subnet down here. It's 10.0.11.175. Let's go ahead and add that. Let's go over here. 10.0.11.175. And I only want this to pick up port 3389. Very good. Now we go to IPv4 policy. We'll create a new policy for this. If traffic comes in on the public side, is going out to the internal side, sourced from any one destination to the VIP, service for RDP, accept it, flow-based, source NAT it. I'm going to leave that source NAT turned on. We'll talk about why here in just a second. All sessions, and we'll turn that on just for troubleshooting purposes while we're setting this up. All right, there we've got that policy in place. Let's go ahead and create a similar policy on our HA pair. Oh, I can't believe this still has me logged in here. Let's see. I don't know what the login timeout is, but I don't think I've been on this thing for quite a while, and yet I still appear to be logged in. I do have one existing policy from the private side to the public side called outbound all. I'm not going to change it. I don't really need it for this lab, but I do need an inbound policy. So what I'm going to do is say create new virtual IP. What do we call this before? Windows Lab RDP? Windows RDP? On the public port, put my mouse over it, 10.0.0.13. And map it to, now this needs to be mapped to Windows in Zone 1. This is my FortiGate HA pair, which is in, here we go, US East 2A. It needs to be mapped to the Windows system in US East 2A. So Windows Private 1 subnet, Windows East 2A right there. Let's see, 10.01.146. Sure, 1001, 146. Also only want this to work for 3389. Very good. Create a policy for this. If it comes in on the public side, and it's going to go out the private side, and it came from anybody, and it's going to the VIP, and it happens to be RDP. Accept it. Flowbase, SourceNet it turned on, all sessions, and again, once again, I'll just do that for my own troubleshooting purposes. Turn on generate log when session starts. Very good. Let's talk about that source netting that I just turned on those policies, because earlier when I created an inbound policy from the internet to allow RDP, I didn't turn on that source NAT. I think you might have even heard me specifically say, I don't need to turn this on. I'm not going to turn on this source NAT. And that was because we were using a slightly different topology. Let's go over here and look at this topology diagram again. In fact, let's not even look at this one. Let's go all the way back to Lab 1 or Lab 2. Lab 1, sure. There we go. Yeah, let's look at this one. When I created that inbound RDP policy, I did not turn on source netting. Let's remind ourselves how traffic was flowing real quick. So with that, I had an elastic IP address, and that elastic IP address was associated with this ENI. So traffic would hit the elastic IP, that would get destination natted by the Internet Gateway Service to that port, which would then get processed by a VIP with policy that sent it to this Windows server. Now, when it reached this Windows server, let's just say that at home, my source IP address when I was doing this was 166.3.2.1, which is not my public IP, but it's an example, right? 166.3.2.1. When this arrived, because I did not have source natting turned on, the source that the Windows server saw was 166.3.2.1. When this destination NAT happened, as I was hitting that elastic IP, that destination natting done by the Internet Gateway does not do a source NAT. So there was no snatting happening here that was changing the source away from the original 166.3.2.1. So when it got to the FortiGate, the original source IP that the FortiGate was seeing was 166.3.2.1. It was not translating it, it was sending it on because of firewall policy, which means that's what the Windows server was seeing. So when the Windows server would send a reply, my drawing has gotten really busy here. Let's erase all this. When my Windows server was sending a reply to that RDP traffic, the reply was going to 166.3.2.1. So it looked at its routing table, and there's two routing table entries there. One of them says to go to the wildcard or the default route, go to that ENI right there. Another one, which is always present that you cannot override. Let's change pen color real quick. Drawing tools, there we go. Pen color, blue. Another one said this, 10.0.0.0/16, go to local. This is a system created VPC route. And what this means is if the destination is anything inside of the VPC, just send it directly to that. So if the reply traffic was going to go to a 10.0 IP address, it would have just routed directly to whatever that IP address was within the VPC. It would not have gone through the FortiGate first. That creates certain challenges sometimes with AWS. In the AWS world, within a VPC, you cannot route traffic east to west within the VPC through the FortiGate. There are other topologies that you can create with things like transit gateways to be able to do things like that, but you can't do that exact thing. If you look at, I don't want to erase everything. I just want to erase this part right here. If you look really closely, but I don't want to erase everything that I've done here, the VPC CIDR Hey, there we go, that'll work. The VPC CIDR is 10.0.00/16. Let's just change this. So that's where this route came from. When you created the VPC, that 10.0/16 route was automatically created. Now, that 10.0/16 route isn't a concern for us in Lab 1, because in Lab 1, when the Windows server received the request from the FortiGate, it was source IP'd as the original external IP address. So when the Windows box responds and it sends the packet out, the private routing table looks at this and says, oh, well, let's just put myself here. So we can move this around a little bit. Yeah. And just erase all this ink. The Windows server sends the response to 166.321. The routing table is checked as soon as the packet comes out, and it says, oh, use the 000/0 route. Send it to the FortiGate. Not a problem. Let's contrast that to lab number 5. So erase all this ink, go back to a mouse pointer, go look at lab 5's topology diagram. There it is right there, lab number 5. Give ourselves a pen again. The elastic IP address isn't associated with the FortiGate. So we're going to hit an elastic IP. It's associated with this elastic load balancer. This elastic load balancer is going to distribute sessions to the FortiGates. When it does, it's going to use a source IP address of itself. It's going to source NAT this traffic as it puts it into a subnet. So it is either going to put it into the public 2 subnet or the public 1 subnet, the original public subnet that we've created. And it's going to have its own ENI in each one of those subnets. Let's choose a different pen color. There we go. We'll choose black. So basically, this load balancer has an ENI here in this public subnet, and it has an ENI here in this public subnet, so that when it reaches these FortiGates, it's being source natted to each of those ENIs. So when it distributes traffic to that FortiGate, it's going to show the source of 10.0.10.something, whatever the ENI is in that subnet for the load balancer. This is a network interface of the load balancer. And I don't know what the load balancer is going to use for source IP. We'll see that when we deploy the load balancer. But that gets tricky. So let's call it, it's going to be 10.0.10.something over here on this side. On this side, it's going to be 10.0.0.something because that's the original public subnet when it uses that ENI. So it source nats it to that address in black as it comes in. Let's change pen color again. We'll go with red, and it arrives on the FortiGate. Let us assume that the FortiGate does not source nat it and sends it on to the Windows server. The Windows server receives the RDP packet, right, and it tries to send a reply to the RDP packet. When it looks at the source IP address, it doesn't see the external source IP of 166.3.2.1, right? Me out there on the internet. It sees a source IP address of 10.0.10.something, whatever the elastic load balancer was using. It goes and looks at the routing table. The packet gets back out of the Windows server. The cloud looks at the routing table, and the routing table has 2 routes. The 0.0.0/0 route that sends it back to the FortiGate, and the 10.0/16 route that was system created that says local. That's going to match the 10.0 route, right? It's coming in with a source of 10.0.10 something. It's going to match that second route. And that means that the reply traffic would skip the FortiGate. Sorry, I'm moving around my drawing in a way that I didn't mean to. There we go. Let's do the reply traffic in blue. So that means that the reply traffic would skip the FortiGate and go back through the load balancer and go back to 166.3.2.1. Now, the user would still get the RDP reply. That part worked just fine, but we have an asymmetric traffic return. And so the FortiGate can only scan the inbound traffic at this point. It can't see the reply on the session. That's going to mess the session table up. It's supposed to be a stateful firewall. We're supposed to be able to track sessions. So as a result of that, we need to source NAT the traffic as it's coming through firewall policy. When we source NAT that traffic, we'll change our pen color back to red. Traffic hits the elastic IP from 166.3.2.1. There we go. The elastic IP is associated with the load balancer. The load balancer source NATs it to its 10.0.10 IP, whatever IP address it was, sends it to the FortiGate. The FortiGate source NATs it to its private IP as it sends it to the Windows server. So this will be a 10.0.11 IP that belongs to the FortiGate. On this side, that'll be what it is. Over here on these two guys, it'll source NAT it to a 10.0.1.13 IP address that belongs to the FortiGate cluster. I don't remember what the .11 IP was on the right side. Whatever that was a moment ago, it's going to source NAT it to that. So when the Windows server sends a reply, yes, it's going to look at that reply and go, oh, it came from the FortiGate's IP, and the routing table is going to say, great, send it back to the FortiGate. So the reply goes back to the FortiGate. Let's change the color of our reply traffic. Pen color blue. There we go. So that reply goes back to the FortiGate's IP, matches up firewall policy. Firewall policy nats it back to the 10.0.10 source of the elastic load balancer, right? And then the elastic load balancer sends it back to 166.3.2.1. When you're using an elastic load balancer with a FortiGate and a topology like this, the FortiGate's going to need to source NAT traffic to make sure that the return traffic comes back to the FortiGate. It doesn't go back through the elastic load balancer. That's why we're source NATing. Which means, by consequence, it means that the Windows server doesn't see the original source IP address. The FortiGate server doesn't see the original the FortiGate firewall, not server, doesn't see the original source IP address. AWS does though. So we would have to use something like flow logs out of AWS or some type of logging mechanism out of AWS to be able to see the original source IP addresses that are hitting this load balancer. It's just not possible in this type of topology because the elastic load balancer is always going to source NAT the traffic. Beyond the scope of this course, it is possible to configure an elastic load balancer in such a way that it does not source NAT traffic. It is possible to do that in AWS. The trick is the targets of the load balancer. In order to have an elastic load balancer not source NAT, you have to configure the targets in a very specific way. This is outside of the scope of class, but we've gone this far, so let's keep talking. These targets would have to be listed by instance ID. So if you can imagine, when you configure targets, there's two ways that you can configure targets. You can do them by instance ID, or you can do them by their IP address. If you do them by instance ID, then it doesn't get source natted. Oh, well, that sounds really good. I mean, we could do that, right? That sounds great. Here's the trick. You can't add an instance by instance ID if it has two network interfaces. You've got an instance here with two NICs. So it needs to understand when I load balance it to that instance that I've circled in blue, am I supposed to be load balancing it to that interface or to that interface? So you can't do it by instance ID. Really, the only way that an elastic load balancer would work in that scenario is if the elastic load balancer was distributing directly to web server EC2 instances, as an example, and those web server EC2 instances only had one network interface. Right? That's an instance, that's an instance, that's an instance. If they only had one network interface, you could list them by instance ID and it wouldn't source NAT. And then within those web servers, you could see the original IP address of the traffic. But since FortiGates are pretty well always probably going to have two network interfaces, that becomes our challenge. We can't list a FortiGate by its instance ID because it's always got two network interfaces, unless we run into a scenario where we're only doing it with a single ENI. So little beyond the scope of the course, but just FYI, because this can be a little confusing because you'll hear me say something like, oh, an elastic load balancer always source nats. And then you'll start doing a little bit of research and you'll go, well, no, there is a scenario you can make it not source nat. There really is. It's just not appropriate to load balancing to FortiGates because they have multiple network interfaces. I hope that that's clear. I hope I didn't make it worse for you by including content outside of the course and really confuse you. I hope I in fact made it more clear for you. All right, so that's why I turned on source natting on those policies. Now let's go ahead and return back to where we were in the lab. Let's go back to a normal mouse pointer. There we go. We'll pull this over here. Let's see, we configured the FortiGates. We've got our Windows servers. We did our FIPS. We've done all of that. I'm sorry, I'm just going through my list of things to do. This is a long lab with lots of little parts and pieces. We're going to need our Windows servers passwords. Let's go ahead and get our Windows servers passwords real quick because we're gonna need that in a little bit. So I'm gonna pull up my notepad that I keep notes on. And we'll go to the instance wizard. Oh, no, don't need that actually, close that. We'll go to the instance list, there we go. Windows, private one. We'll just right click on this and say, get Windows password. Choose file. My PEM file that I created a little earlier. Decrypt the password. And I'm just going to Control C, highlight all of that. This is Windows Server Private 1. This will be Windows Server Private 2. Well, oh, maybe it's because I have this highlighted. There we go, close. There we go. I don't know why I was having so much trouble with my mouse. I have been having trouble today, I suppose. All right, let's go get Windows Private 2. Get Windows password, choose file, same file. Open, decrypt password. So what I'm going to do next is go ahead and RDP into the Windows systems and sync up their passwords. I'm going to be using RDP and load balancing, so I won't know when I make a connection to the load balancer which system I'm getting RDP'd into. So I can't have two separate passwords because then I won't know which one to connect to. So I'm going to go to each one of these individually, RDP into them, and change their password to something common between them. So let's put the password to the side. I'll need that here in just a moment. Let's go ahead and MSTSC, we'll pull up the terminal server client. Here it is, my terminal server client. I'm going to use the public IP address to be able to reach them. We'll start off with the one that's in zone 2. So this is the public IP address that currently points me to my FortiGate in zone 2, or zone B. There we go, took a moment. More choices, different account, localhost, / administrator, password, grabbing this just off the notepad and my other screen. Well, here, we'll put it over here so you can see. Notepad and my other screen, Control C, Control V, click OK. While this is bringing up the RDP, I'm going to go ahead and start an RDP session to the other Windows server. One in private subnet 1. The one in private subnet 1 is working through the FortiGate cluster, so I need the public IP address, the elastic IP address from, here, let's see if we can make this full screen. Quick. I need the elastic IP address from here, so this 3.19.81.18 IP address, that should work fine. Copy, and MSDSC. A second copy of RDP going there. There we are. More choices. Use a different account. Local host administrator. And that really long, crazy password right there. Copy. And go ahead and get that rolling as well. While we wait for that to come up, go into settings. Go into accounts. Sign-in options, I think, is where it's at. Change your password. Indeed. There we go. So let's get the really long, crazy password again. Control C, Control V. So that's the really long, crazy password. Next, new password. I hope I don't need a password hint. This is only going to exist for about 30 minutes, so if I need a password hint, I'm in real trouble. There we go. Next, and finish, and it's changed that password for me. Now I'm going to go do the same thing to the other system. There we go. I guess I could have just gone to settings that way instead of search for it. Accounts, sign-in options, change. Now I need my original instance ID based password, or this password right here. Yeah. Copy and paste. And yep, that's the one. New password. There we go. Just making a little silly password hint because I think it's silly that they give me the option. Very nice. So here we go. Both systems, there they are, have both had their password changed. Their password is identical. I don't really need to keep a connection open to these right now, but I'm going to go ahead and leave them. I'll just minimize them down for the moment. I can't think of anything else I'm going to need with them in the next few minutes anyway. Okay, we have synced up passwords. We have FortiGates with VIPs configured on them. Now we need an elastic load balancer that sits in front of those VIPs and distributes traffic to them. So when we are done, I should be able to make a connection to that elastic load balancer, and I won't know at the moment that I'm making the connection, I won't know which of those two Windows systems I'm being connected to, so I just put in the same password. And as I go through the process, I should be moved back and forth between the two Windows systems as it load balances them between. So let's go ahead and put this to the side. Don't need this. Next, we need to create our load balancer. I'll go into load balancers under the EC2 console. Oh, this is new. I don't think we've visited this before. Load balancers can be found underneath the EC2 console. I do not recall them being under the VPC console. They might be in both places, but if they are, it's the same options, whichever way you choose to get to it. We'll say create a load balancer. It's going to ask me what kind of load balancer I want to create. I thought I clicked it. I guess I didn't. There we go. Application load balancer. This is a layer 7 load balancer. So this can load balance HTTP and HTTPS requests. Network load balancer. This is a layer 4 load balancer. It can load balance TCP, UDP, TLS, or SSL if you prefer to think of it that way. And then classic load balancer. This is something that you will use if you are not using VPCs. If you have been an AWS customer for a very long time, you might have the EC2 classic network, which is something that predates VPC networks. That's not us, so we definitely don't need to use the previous generation. We are not using a web server. If we were using a web server, it might be interesting to do an application load balancer. So we're just going to do a network load balancer, create. We'll call it Lab ELB. It's going to be internet facing, so it'll be publicly accessible. We need a listener on port 3389. You'll notice that it defaults to port 80. It defaults to creating like a web application. There we go. Do I need to click that twice? Nope, I didn't really need to click that twice. Very good. In availability zones, we need the lab VPC. There we go, the lab VPC. And we need to be able to plug it into both US East 2A, where we have FortiGates, that's where the HA pair is, and US East 2B, where we have the standalone FortiGate. Within that, we need to be able to select a subnet. Now, the subnets that we choose should be the public subnet within each one, public and public 2. And you'll notice, for instance, that I can't choose public 2 on the first availability zone, right? It knows which subnets are in which availability zones. IPv4 address. A little bit earlier, I mentioned to you that the load balancer will have an ENI in each subnet it's load balancing into. First of all, why are we load balancing into the public subnet? Because that's where the VIP is running, right? The VIP on the FortiGate is on the public side. So that's why we're load balancing there. The ENI IP address that gets assigned, this is where that's happening. So we could actually go in and assign it, but it is going to have an ENI within each of those subnets. It says choose your availability zones and subnets with care. After you create the load balancer, you cannot disable the enabled subnets. You can add new ones, but you can't remove the ones that are already there. So we're going to go to security settings. I don't think we have anything to change. Oh, I need to take out that space. Sorry, it gave me an error because it didn't like my name. I could have a hyphen, but I cannot have a space. There we go. So under security, there's nothing for me to do here. This is not a TLS load balancer. It's not terminating an SSL connection. So there's nothing for me to do here. Let's go ahead and say configure routing. And we need a target group. So the target group is going to be what we're load balancing to. So the target group's going to need a name. It's going to load balance to FortiGates. Notice the target type. Do you want the targets to be instance or IP? Do you want to list them by instance or IP? You recall just a few minutes ago, I stepped outside of the realm of the course and I said it is possible to create a load balancer that doesn't source NAT. This is how that would occur. Your target type would have to be instance. And then I said, but we can't do that because our instances have multiple ENIs, multiple network interfaces. And so it wouldn't know which network interface to load balance to. It would confuse the configuration. So we have to choose IP address. On the targets, it's going to be TCP port 3389. For our health check, it's going to do a health check against TCP. It's just a layer 4 health check. Will the service respond? Basically, is all that we're doing there. There are some advanced health check settings, and I'm only going to show this. We're not going to change them, but I'm going to mention them because I mentioned them to you earlier. I said we could tune some of this. Let's see. When we do the health check, what port should we try to open? Well, by default, it's going to try to open port 3389. Every once in a while in the load balancing world, I've run into a scenario where somebody wants a health check to try to make a connection on an alternate port, usually based on something the application does. There's some kind of application reason for doing that. Well, if I needed to, I certainly could. I could tell it, don't use the traffic port, use this other port for the health check instead. So I could, if I was inclined to, let it make a connection to port 443. And as long as it could make a connection to port 443, it would be able to consider the health check as passed. But I want it to actually flow through the VIP and try to make a connection to the Windows server, which the VIP is filtering for only port 3389, so the traffic port makes sense. Healthy threshold, and if you want an explanation for these, little infographics are really helpful. How many health checks it has to pass before something is considered an unhealthy target? I think there's a little bit of a goof here. Before considering an unhealthy target, I believe that's actually reversed. I believe this is how many it passes before it's considered healthy. So number of success before it's considered a healthy target. And then the unhealthy threshold is the number of misses or failures before it's considered unhealthy. How very funny. Considered an unhealthy target. We found a little typo on AWS. That's kind of funny for me. All right, so I'm going to go ahead and set it the lowest so that it can be. I'll set it to 2. Timeout, 5 seconds. So if I mouse over, health check, let's see, the amount of time in seconds during which no response means that it failed the health check. Very good. And if I put my mouse over that again, there was a little bit more. HTTP health check 6 seconds, TCP health check 10 seconds. Wonder if we can make this. Nope, we can't type anything in there. Let's go ahead and make the interval a little bit shorter. The reason I'm going to make the interval a little bit shorter is it's going to have to go through 2 intervals before it considers the Windows server even initially up. So rather than waiting a full minute for that, we'll only be waiting for 20 seconds. Very good. Next, register targets. Very good. Now in the earlier screen, I said I wanted to list my targets by IP address, right? And that's why on this screen, you see things like specify 1 or more IP addresses to register as targets, not instances. It wants to know within this VPC what to make a target. So we need to have 2 things in here, the private IP, the IP address within the public subnet of the FortiGate cluster and of the standalone FortiGate. Well, the FortiGate cluster is pretty easy for me to remember, 10.0.0.13, because it was part of our CloudFormation template. Now, if I wasn't absolutely sure, I could go in and say, let's move this fella out of the way here. FortiGate 1, network, interfaces, and I see on the public network 10.0.0.13. I could just go and look, but I recalled it and I happened to recall it correctly. You know, the one that I didn't recall was the standalone FortiGate. So, and I could pull this off the FortiGate, which is where I'm going, or I could go over here and look at my list of EC2 instances. I could look at maybe I didn't want to log into the FortiGate. I could look at the FortiGate in zone 2 and its public side IP, which is 10.0.10.110. Or I could click on ETH0 and look at it there and see 10.0.10.110. So either way, I got to the same place, 10.0.10.110. So let's add that to the list, and let's also say 10.0.10.110, add to the list. So this is who we're going to load balance to. And you'll notice when it added it, it looked at the IP address, it figured out what subnet that was in, where the availability zone was. So next, and review. This just kind of gives us one more chance to look at what we're about to do, make sure that we configured it correctly, and then click create at that point, starting to kick off the process. All right, Lab ELB was created successfully. Let's go look at it in our list there. Let's go edit attributes on it. There is an option in here for cross-zone load balancing. It'll show up on the bottom of the list, if I recall. Edit subnets, edit attributes. Yeah, cross-zone load balancing. Now this is kind of interesting. This allows the load balancer to, even though an ENI, it goes out of one ENI, to send to a target in the other, in another subnet. So we could go in, and this is, I mean, conceptually, it's kind of hard to think about, but imagine that a request came out of the ENI in subnet 1, in public 1, and then got load balanced into public 2. Just to make sure that everything was being distributed evenly. So let's go ahead and look at this. Load balancing distributes traffic evenly. All targets in the availability zones enabled for the load balancer. Enable. Regional data transfers, everything's in our same region, so I'm not worried about that. Let's go down to target groups. When we went through this creation process a few minutes ago, we created this FortiGates group. These are all the settings that we gave it. Use port 3389, TCP, the target type was IP address, the load balancer. So it's, I like to think of it this way. The target groups is the pool of resources that we're load balancing to. The load balancer is the listener that's attached to that, if you will. So these two things go together. I'm kind of stalling for a little bit of time, and I'll tell you why I'm stalling. I'm waiting, targets, there we go. And I'm still waiting. I didn't stall for enough time. I'm waiting for our targets to initially come up. So you'll see this target registration is in progress. And then once the targets are registered, they'll have to do, the way I've configured it, they'll have to do at least 2 health checks that succeed before they are marked as healthy, which once they're healthy, that means they're up and they'll be load balanced too. So this is going to take a couple of minutes. If you're following along on your own, I would say it's going to take at least 2 or 3 minutes. I've probably had it take as much as 4 or 5 initially registering the targets. It's a good time for us to take a break. So I'm going to go ahead and leave my screen right where it is, pause the video. We'll come back in a few minutes and we'll refresh the screen and see where it's at. Be back soon, everybody. Well, I've unpaused the video. And I haven't moved the screen at all. It's only been a minute or so, but I looked up and I noticed that although it had not completed yet, it did something kind of interesting. You'll see that I've got the 2 targets, 10.0.0.13, that's the HA cluster, 10.0.10.100, that's the standalone FortiGate. There's my 2 targets right there. And initially, 10.0.0.13 is already showing up as healthy, 10.0.10.100 is showing up as unhealthy. Now, I have seen this happen before where for whatever reason, initially, when it first comes up, it's marking it as unhealthy. Let's just click refresh. Well, let's see if we can determine. I'm going to close my RDP connections that I've got running out here. So close this one and close this one. And what I'd like to see is if the health checks are actually arriving on 10.0.10.100, which is the FortiGate. So we can go to the FortiGate and do diag sniffer and try to attempt to see if that's happening. Let's go over here. Looks like I might got lucky. I started a log on over here earlier, so I didn't have to put my username and password. We'll just go to network interfaces. We're going to double check that I do have the right IP, 10.0.10. Oh, look at that. Look at that. I don't know if you guys saw this in the video and you caught that I made this mistake. I promise you I didn't make this mistake on purpose. I wouldn't, I'm foolish all the time, but I'm relatively rarely foolish on purpose. So let's do this for, you know, if we followed this through, I would probably come in here and I would do something like this. Diag, sniffer, packet, port 1, TCP 33, actually, I'm not gonna say that, I'm gonna say port 3389, verbosity level of 1 should be okay. And I can leave this here and oh, look at that. There actually is something coming in. Looking at the source of that traffic, though, don't think that's the health check coming 10.0.10, 110. Let me come back to the load balancer. Yeah, this is just me. I just made a simple goof up. I meant to do 10.0.10, 110. I did 10.0.10, 100. I will go back and yeah, it was correct here. I looked at it. You guys probably saw me make this mistake and giggled at me at the same time. That was fair game. That was a fair giggle. I'm a human being. I goofed it up. So let's go see if we can make a change to that target. Go back over here to target groups. Certainly, I don't want to, let's see if I can go in here. I don't see an edit option, but you know what I see? I see a deregister. Let's deregister this one. Target deregistration is in progress. Let's register another one. Lab VPC 10.0.10.1110. There we go. Status is pending. Register pending targets. So we now see 10.0.10.100, my original goof up, in a status of draining. What a great status. I don't think I've seen that before. I probably have, but I didn't notice draining. So that's the one that I'm deregistering, that I'm deleting. And 10.0.10.110, which is now in a registering process. And I'll hit refresh. All right, well, now I'm back into the wait and see mode, and I do expect this will take at least a minute. So I'm just going to leave it here. I'm going to pause the video. We're going to come back and see what it does. Okay, welcome back. It's been a couple of minutes, and there we go. I see we now have 2 healthy registered targets now that Ray has correctly typed in an IP address. And the draining target actually just removed itself from the list on its own just a moment ago. In fact, if you go back and you play when I first unpaused the video, it was actually still there and it said draining and it just disappeared. Okay, very good. I think we have all of the pieces that we need in order to start to test our load balancing. So what I'm going to do is the load balancer actually resolves to a DNS name, a public DNS name. Let's go back to load balancers, availability zone, creation time, DNS name. There it is. I'm just going to copy that right there and add it to my clipboard. It's this DNS name that we see right there. I've just clicked this little button to copy it. Let's go ahead and open this up. STSC. Now, the only thing that's a little bit tricky about using RDP as a test is these Windows servers will only allow a single RDP connection. Let's go ahead and say more choices, use a different account, local host / administrator, and the password that I changed this to a little bit earlier. So these Windows servers will only allow a single RDP session simultaneously. So right now, if you look at the top right-hand corner, that is, circle this with my eye, let's do drawing tools, spotlight right there, 10.0.11.175. This is in the 2B availability zone, okay? If you can imagine, I'm not the only one who is running connections to this elastic load balancer. Even as I sit here for just a few moments, I can pretty much guarantee you that someone else has already tried to port scan this load balancer, is checking to see what ports are open on it. It's a pretty non-stop process, people trying to make connections to your load balancers or to your elastic IP addresses, which is why things like a FortiGate become so very important. So sometimes I'll go in here and, no, we got really lucky this time. Sometimes I'll go in here and I won't get load balanced to the second unit. I'll get load balanced to the first one again, and I'll actually bump off my first connection. And the reason that that happens is because someone somewhere else is hitting my load balancer at the same time. But there we go. I see both of them now. So spotlight, right? 10.0.1.146, 10.0.11.175. This one's in availability zone A. This one's in availability zone B. I am being load balanced to both at the same time by the load balancer. So I suppose the next question is, yes, but is traffic actually flowing through the FortiGates? What we can do to answer that question is go back to a FortiGate, log into it, and while that's being logged in, we can go under the other set of FortiGates, IPv4 policy. I can say Windows Server Lab RDP. Let's show matching logs to that. And while that log list is coming up, I'll do something similar on the standalone FortiGate. Policy and objects, IPv4 policy. I mean, just based on bytes, I know that there's some kind of connection there. Show matching logs. There we go. And indeed, I do appear to have sessions flowing on this one, and I do appear to have sessions flowing on this one as well. Reality is it's going to get a little bit hard figuring out which ones of these sessions are me and which one of these sessions are health checks, because you'll notice they're coming from these IP addresses 10.0.0.76, 10.0.10.98. These are the ENIs of the Elastic Load Balancer in public subnet 1 and public subnet 2. And because I have cross-zone load balancing, it's actually running health checks from both ENIs to both FortiGates. So if I went to the other FortiGate, we would also see log entries from 10.0.0.76 and 10.0.10.98. So it'd be a little bit hard to sort this through. I could probably sort through it just based on who actually finishes a session and how many bytes they have in that session. I could probably sort out which traffic was actually me. Very good. They're both there and they're both doing their job. Well, that is the end of lab number 5. Lab number 5, just to remind ourselves what we did. Go all the way back to that lab topology diagram, bring it over here. We put a load balancer in front of a set of FortiGates so that we could have what is effectively active-active load balancing. If one of these FortiGates, let's say for the sake of argument, this FortiGate fails, as soon as the load balancer notes the failure and marks the target as unhealthy, it begins load balancing to these FortiGates. Now, there are some things that that we could look at doing, like FortiGate session protocol to keep the session tables in sync, so that the other session could be waiting on the FortiGate for it if it had to be load balanced too. That could improve this a little bit more. If there was a shortcoming to what we've done here, it is the static nature of what we've set up. We have a set of FortiGates, erase all the ink here, that we're load balancing to. What if tomorrow morning, let's say that for instance that this is load balancing not to this Windows server, but to some kind of web server, right? That's what it's load balancing to, some type of web application. Let's say tomorrow morning, our business becomes incredibly successful. We're selling a widget, and that widget becomes critical to the world at large overnight. Like, I don't know, mask manufacturers in the COVID-19 world, mask manufacturers became critical overnight. And all of a sudden, we have a high volume of web traffic. And our 2 web servers and our 2 FortiGates that sit in front of these web servers are no longer sufficient to process all of the traffic. So we have customers who are trying to come to our website and buy our masks or buy our widgets, and they can't because the website is running too slow or they're getting disconnected because there's only 2 web servers or there's only 2 FortiGates being distributed to. There's a functionality within AWS called autoscale. And autoscale allows you to take a group of EC2 instances and automatically scale them out as load increases or activity increases, and automatically scale them in as load decreases or as activity or volume decreases. This ability to be elastic is where a lot of the features within AWS gets their name, the elastic load balancer, elastic compute cloud instance. The general idea is if you need 2 web servers today, well, then let's have 2 web servers. But if tomorrow you need 20, let's have 20. And let's only pay for 20 when we need them. Let's allow it to scale out automatically and scale back in automatically. And there's a lot of solutions. If you go Googling out on the internet, there's a lot of solutions that talk about auto scaling to support applications like web servers to be able to scale out and scale back in automatically. Well, if you're auto scaling out your web servers and you're auto scaling in your web servers, it makes sense that you might also need to auto scale out your FortiGates or auto scale in your FortiGates, because as the volume of traffic that your web servers are processing has gone up, invariably the volume of traffic that your FortiGates are processing has gone up. So in lab number 6, we're going to take a topology that looks very close to what we've done here, only we're also going to add in an auto scale functionality. We're not going to worry about auto scaling the web servers. That's a little outside of the scope of a FortiGate class, of a cloud security class, but we are going to set up an auto scale group to auto scale out our FortiGates. That's what I'm going to show you in lab 6, which will be the video after this one. So on that note, if you're following along and you plan on doing lab 6, we are not going to use any of the resources that we have created so far to do lab 6. We'll have a complete new set of resources. So what I'd like to do before we finish this video, since some of you I know are going to do some of these labs to try to follow along on your own, you're like me, you like to have your hands on, I'm going to walk you through deleting resources. Let's go ahead and close a few things. Don't need this. Certainly don't need that. There we go. Let's go back to the AWS console. Now the HA cluster, there's effectively 2 ways that we could delete the HA cluster. One of them would be going back into CloudFormation, and I actually do like this way quite a bit. It's very handy. Choosing the stack that we created earlier and choosing delete. And when you delete the stack, it will delete any resources created by that stack, by that CloudFormation template deployment. And I'm going to go ahead and do that. Now, if I chose not to delete it this way, or if for some reason I got an error when I was deleting it this way, we could still delete all of those resources manually, and I'll show you what that looks like on the other resources that we delete. So let's go ahead and delete the stack. It says deleting this will delete all stack resources according to deletion policy. Let's say delete stack. And it says deletes in progress. I know that's going to take several minutes. While we're waiting on that to complete, let's go to the EC2 console. I'm not going to delete the HA FortiGates because the stack deletion should take care of that for me. In fact, you can see the HA FortiGates are already starting to shut down. I am going to choose the Windows servers and the FortiGate standalone, the FortiGate Zone 2, and say instance state terminate, which is effectively delete. Yes, go ahead and terminate them. And that will take a few minutes. So you're not sitting here watching little progress indicators go by. I'm going to pause the video and I'm going to unpause the video once it's moved from the shutting down state into the terminating state. So pause and I'll be back in just a moment. All right, very good. That's probably been a minute or 2 since I paused the video. I looked down, I did 1 or 2 things, I looked back up and it said terminated. So let me go ahead and, sorry, my phone was making a little bit of noise there that we don't need in the video. So we've got those. Let's go take a look at a few other things that might still be out there. Let's go to the EC2 dashboard option at the very top. When I look at the EC2 dashboard option, I see running instances, snapshots, key pairs, elastic IPs. There's no elastic IPs, that's fine. Key pairs, yes, I do have a couple of key pairs out there. I've got that lab key pair that I created. I'm not gonna delete that. That still may come in handy. So that lab key pair, I'm gonna hang on to. Load balancers, indeed. neither my CloudFormation template deletion or the deletion of those VMs deletes the load balancer. So let's go see about that. Let's go load balancer. And we'll choose delete. Yes, delete it. Target groups. Might need to delete those separately. We'll find out in a moment. Yeah, there it is, still there. So we'll take the target group, actions, delete. Very good. And in case you're using the older EC2 experience, I'll just switch over to that other version of the console. That's fine, I'm satisfied with it. There we go, submit feedback. Please don't send me an email, you guys. There we go. Let's go back to the EC2 dashboard just to kind of compare, see what the dashboard looks like. Same kind of display, right? It just looks a little different. 3 key pairs. I do have some security groups. I'm going to leave those in place just for a moment. All my Elastic IPs are gone. Let's go over to VPC and try to delete the network. VPCs will try to delete a lot of different objects for you. It'll try to delete the internet gateway, the routing table entries, the subnets. Let's go ahead and see if it'll let us delete. And I said, see if it'll let us, because the nice thing about deleting the VPC is if there are, for instance, ENIs or security groups that still exist, it won't let you delete the VPC. So I left the security groups there on purpose because I wanted you to see what this looks like with this error. Now, this error happened to be for a security group. It says API error message, resource SG073. SG, it's a security group. Security groups are SG resources. ENIs would have started with, Elastic Network Interfaces would have started with ENI. Basically what this is telling me is I need to go delete the security groups. So I'm gonna hit cancel and we'll go back to the, actually, you know what, hang on just a second. I don't think I have to go back to the EC2 console. Yeah, security groups. The VPC console has security groups within it. I should be able to delete all of these except for the default. I don't believe it'll let me delete the default one. So let's say actions, delete security group. No, this is actually giving me an error because there's still a network interface out there. So the problem was it couldn't delete the security group. And the reason that it couldn't delete the security group is because there was still an ENI out there. Following security groups cannot be deleted. It has one or more network interfaces. So the standalone FortiGate that I made a little bit earlier, the FortiGate Zone 2, recall that when it was created, it did not include the second ENI. So I have at least that ENI that needs to be deleted. Let's go to network interfaces. Yep, there it is, the Zone 2 private ENI. So we'll delete that. Yes. That actually makes sense because as I think about it, the VPC delete should be able to delete those security groups since there are no longer any dependent objects. Go back to VPCs, your VPCs, actions, delete the VPC, delete. Very good. Your VPC was deleted. So if I go to the VPC dashboard and I look now, basically the only thing that doesn't show up as zeroed out is this DHCP option set. Doesn't let you delete that one for whatever reason, but it's not a resource that charges you money. It's like a settings for your VPCs when they get deployed. Let's go do some other deleting. If I go to S3, during the CloudFormation template, lab number 4, I had to create an S3 bucket. The S3 bucket was used, as you recall, to hold my bootstrap config. It was called raslan 0908 2020. So if we look at that and we click on it, let me go back to that for a second. It is noteworthy. There's 2 versions of the console. You might be looking at this version of the console, or you might be looking at I'll click the switch to new console, or you might be looking at that version of the console. In either case, we need to delete these buckets. The buckets can only be deleted if they're empty. So in either case, you click on the bucket, you look at the contents of the bucket, there's my two FortiGate config files, and you go to actions, and it'll be a little bit different in the other version of the GUI. You delete whatever's in the bucket. Delete. Then I'll go back to S3, go into the other bucket. The other bucket was created automatically when I did the CloudFormation template deployment. The JSON file got uploaded into an S3 bucket that was automatically created for me. So I can go in here and say actions, delete, goodbye. Now I can delete the buckets. In order to delete the buckets, they have a sort of safety mechanism. If I say delete, it'll say, great, type in the bucket name to confirm it. That way I can't just accidentally click it. You have to very explicitly, now I'm not gonna type in the bucket name because I'm lazy. I'm just gonna copy and paste it right there. So, except it looks like maybe it's got a space in there. Yep, there's a space. There we go. Now, once I've typed it in exactly as the bucket name is specified, I can click delete bucket. Goodbye bucket. We'll do the same thing for this one. I'll just copy its name real quick, Control C, delete, delete bucket, goodbye bucket. One last place I want to look, just in case we didn't delete it earlier, all the way back in lab number 2, we created a credential for the cloud, the Fabric connector to log on. So if I go to IAM, right, Identity and Access Management, I go look at users, there may still be a user out there. I don't have any other users out here. I only have Home Firewall, which is a user account. I'm going to go ahead and, nope, not going to delete that. I was thinking about deleting it, but I'm not going to. I just realized I do still use it for something. So you may have, if you have a user out here that we created earlier, go ahead and delete that user account. It's not that option. I wanted the EC2 option. So my VPC is gone, and all of the related objects to my VPC is gone. My instances are gone. The key pairs are the only thing that I still have out there. I'm going to use those key pairs for, I'm at least use one of those key pairs for lab number 6. Well, very good. That's the end of this video. I will see you all in the lab 6 video. Thanks a lot, everybody.